Hi everybody, so in the previous video we solved this problem uh, but without doing a differential equation. How to solve this problem directly without doing any equivalent circuit. The advantage of this is that it's straightforward. Okay, so you have two different methods. The previous method is quite long but easy. This method is straightforward but you need to be careful. And a straightforward method to solve any problem in circuit, what is it? That's junction rule and loop rule. In other words, Kirchhoff rule. So let's use Kirchhoff rule here. So let's name our current. So we have a current going from the battery, I call it I1. This current, it will be divided in two. This is I2, and this I will call it just I for simplicity. So that's the current in a capacitor. In the previous video, I call it small I, so here I will call it small I2. Let's draw our loop. That's my first loop, simply, and that's my second loop. And let's write the loop rule and junction rule. Junction rule, what is state? I1, we are expert now, is equal to I2 plus small I. Second loop, or let me write this one first. Ri2 minus Ri, and here, well, we are charging capacitor, that's positive side, that's the negative side, so the potential is decreasing, so this is minus Q over C equals 0. And I, what is it? I is dq over dt. So this is my differential equation. The second one, here there is no capacitor, so this is E minus Ri1 minus Ri2 equals 0. So as you can see here, that's my differential equation. Everything is ready, but I don't know I2, so let's use this two equation to find out I2. So I replace this one in here. So you have E minus R, what is I1? That's I2 plus small I minus Ri2 equals 0. Okay, so from this what you get, so you can get Ri2 equal E minus Ri over 2. And you take this and you plug it here. Okay, you take the Ri2 and you place it here. So what we will get? E over 2 minus Ri over 2 minus Ri, you get 3 half Ri minus Q over C equals 0. In other words, E over 2 minus 3 half R dq over dt minus Q over C equals 0. That's my differential equation. So as you can see, in few steps, we get differential equation. Now, how to solve it? All right. So just remember the simple RC circuit. You need to remember here the differential equation of simple RC circuit. If you don't remember it, just draw it and you get it easily. So what we have E minus R dq over dt minus Q over C equals 0. That's from your lecture note and so on. Right, that's from the book also. So that's the simplest differential equation. And from here, what we get the charge equal to what? Q infinity, which is CE, 1 minus exponential minus t over tau, and tau equal RC. In other words, what is the charge infinity? That's C times E, this one. What is the tau is C times R, this one. So let's compare this equation to this one. What replace E here? E over 2. What replace R here? 3 half R. And the C is the same. So we can write directly the equation just by analogy. I don't need to do calculus here. Qt, that's what? Times this, e over 2. 1 minus exponential minus t over tau, that's straightforward. What is tau? 3 half RC. And we are done. We are done in few minutes. Compare it to the previous solution, but just you need to be careful by writing the Kirchhoff rule and by solving it and writing the right differential equation and do analogy with this to get your solution. Okay, thank you for watching. See you in my next video.